Very, very good, everyone. We are up on the hour, so let's give the audience a couple more minutes to log in. We can see more folks are joining us as the seconds fly by. But in the meantime, let me open up and introduce the topic of today's webinar session for everyone. So we will be discussing, and again, that's why I'm appropriately dressed here, also in the coolish climate in the Nordics, not quite in the extremes of the Arctic, which is going to be today's session, or close to the Arctic on the Norwegian continental shelf, but I'm sufficiently out in the archipelago and it is cold here alike. So today we're going to be discussing how one goes from the depths of 4,000 meters into the cloud. And of course, why are we doing this, and why are customers and partners doing this? It is all about making structural integrity analytics go to the next level through liberating data from extreme conditions and closed in siloed systems, so that we can drive genuine customer value at scale in the era of the cloud. So before introducing the pristine speakers today, let me just go through a couple of housekeeping matters with you first. Today's session is going to be about half an hour of presentation. We're a little bit flexible there, and then we have a Q&A at the end as well. So for those of you who do have questions, or when questions do pop up into your mind, please don't hesitate to post the questions into the questions chat box in the webinar tool. This webinar is co-presented by Force Technology Norway as well as Equinor, and us as Cognite, we will be doing the moderation and the hosting for you today. The webinar is being recorded, and the recording is made available for everyone after the fact as a recording that is available on demand on cognite.com, and it will be emailed to you as well after the webinar broadcast itself. And again, for questions, please do not hesitate. And if we cannot address all the questions today in our due time slot, then we do promise to get back to you individually by email after the fact. And again, you are free to present questions to the individual speakers, or then you can just generally post the questions to anyone and everyone, and we'll take them on our rightful turns. And again, last but not least, thank you once again for joining us today. We do sincerely appreciate your participation. We know it's a busy time. There's lots of content available online these days, and we do genuinely appreciate you taking the time out of your busy calendars to join us today for this fantastic session. So the goal for today is really to go through a couple of very, very interesting and challenging things that our customers have achieved through data liberation and through advanced analytics using that data. And we'll be discussing customer value delivered by Force Technologies by unlocking the full potential of real-time advanced sensor system analysis in the cloud. We'll also be touching upon how to overcome challenges in monitoring structural integrity across equipment in highly challenging environments. And I do mind you that the conditions in which I am right now is no match to the conditions we'll be discussing today. Then we'll touch very quickly on data liberation from proprietary source systems with proprietary data structures, of course, and how those can be brought up into the cloud for rapid cloud data analytics, and of course liberating that data from those siloed source systems and made it available for an advanced querying data model. And then, of course, using real-time data flows that are contextually mapped to the physical asset models. So talking a little bit about digital twins and how that relates here, to delivering both general analytics as well as bespoke solutions rapidly. And at the end, we'll take your questions as well as we can. And please do challenge us on the questions, and we'll do our very, very best to answer them for you today alike. So with you today, we have a good set of speakers. I will go into the background very shortly and instead give the stage over to our actual presenters and the experts on the call. So we have Paul Tuset from Force Technology, and he will introduce himself very, very quickly when I hand over the baton to him shortly. We have his colleague, Alexander Alike. Alexander is Vice President for Structural Integrity and Environment. And of course, Paul is a technical expert equally on structural integrity and environment. And we also have Equinor joining us today. And it will be Trond presenting from Equinor. And he is the lead subsurface data engineer for drilling and wells at Equinor. My name is Petteri Vainikka. I'm Vice President for Product Marketing at Cognite. And I'm genuinely excited to have you all join us here today. So without further ado, I'll open the floor. But before I hand it over to our expert speakers today, I will give you a little bit of a context setting as to who is Cognite and what do we do. Our flagship product is called Cognite Data Fusion, and it is an industrially specialized data ops and AI platform that enables heavy asset customers such as Force Technologies here to operationalize and scale their digital programs to unlock return on investment at scale. So we really focus on making industrial data flow from any source system anywhere on the planet, be that in the depths of 4,000 meters, as in this case, all the way into the cloud so that customers can deliver and deploy very, very high value, agile analytic solutions based on that data. And with that, I will not dive more into our role, but instead I'll hand the baton to our esteemed speakers. And first up is Alexander. He's a vice president for structural integrity, as well as, of course, Paul, who's our technical expert. And they will start by setting the stage and explain a little bit about what Force technology is, and then we will go into the use case, and then that is where we'll have Equinor join us as well. So, gentlemen, I will hand over to you here and now, and please do just ask me to change the slide at the appropriate time by raising a finger saying next slide, please. With that, I'll move to the first slide.
Thank you so much, Petteri, for that introduction. So I'll start by saying a few words on who Force Technology is and where we come from. So Force Technology is a technology consultancy and a service company which strives to create positive technological change and make the world sustainable and safer. As a non-profit company, we exist to help others, and it's our duty to help and lead the way and help companies become the technological and sustainable front runners. So Force Technology is based in Denmark, but we have offices in Norway, where me and Paul sits. We have offices in China, Singapore, Abu Dhabi, and in total we are around 1,100 employees. As mentioned, the Force technology is a driving force for technological development, and in that we have some pretty unique testing facilities and laboratories that ensures testing, demonstration, and documentation of new technologies and products. We have wind tunnels, large water tanks, electromagnetic noise and vibration facilities, and even we are doing full-scale testing of jacket structures and windmill blades. So we provide services to thousands of international clients, both private and public, every year. And we comprise of numerously highly specialized business areas, offering services to clients for the first idea through development and testing and up to certification and testing. Next slide, please, Petter. So talking a bit more about the Force technology and what we do in Norway. So in Norway, we are built up around the oil and gas industry. And since 2003, we have applied our expertise in ensuring asset integrity of offshore and onshore installations, using our knowledge in structural design, advanced inspection, cathodic protection, structural monitoring, and materials optimization to keep assets safe for our customers. These are all services that we now start to employ, or have been for a while, employ in the new renewable energy business, where we see many of the same challenges, although slightly different. At the moment, we have several ongoing projects working for the offshore wind industry, where we perform design of foundation structures, cathodic protection optimization, and structural monitoring of wind turbines. In addition, we perform training and certification within NDT and welding and multiple other areas. And also we are building up our clean air technology department that helps the industry limit the release of harmful substances to the atmosphere and stay within the limits set by the government. But let's go deeper and see what we do in structural monitoring. Next slide, please. So the ForceSense monitoring product range have two main product areas. To the right, we see the flexible riser products consisting of vent gas monitoring and polymer coupon monitoring. With the vent gas monitoring, we measure the pressure buildup in the annulus of the flexible risers and how this develops over time. This way, we can detect ongoing degradation and provide early warnings to avoid costly failures. Polymer coupon monitoring is a more direct approach where we insert physical samples of the liner materials into the hydrocarbon production fluid stream and measure the degradation of the polymer over time. To the left is our load and response measurement solution, where we provide systems to measure and collect data from various sources such as strain, acceleration, waves, wind, and currents. Such data are highly relevant if you want to know how the structures really behave and what loads it has actually seen. In particular, such data can be very valuable if you want to extend the lifespan of an installation beyond what it was originally designed for in the first place. This is also very useful data to take back to the structural model and use to calibrate the model to more accurately represent the physical model, building the digital twin. By working with Cognite, we have now a simplified route to link the data and transfer the data up into the cloud in a safe and secure manner. Before Cognite, we developed our own cloud solution and dashboard using our own in-house experts. However, these resources are in very high demand and are pulled in all different directions. By working with Cognite, we have freed up these resources to work on the next generation technology prototypes and other cutting edge solutions. And instead, we have an industrial platform that is robust, scalable, and safe. And this allows us to focus on what we are really good at, and that is putting together sensor packages, battery solution, and electronics modules for data collection, in addition to using these data to improve our digital models for accurate modeling of the behavior. Let's look at some of the examples that we have been working on. Next slide, please. So Paul, I leave it over to you.
Thank you. The first example of a structural condition monitoring system is from the subsea drilling part, where we collect and process data from drilling operations, either looking at data that has to do with wellhead fatigue, loads going from the BOP down into the subsea wellhead, or on the BOP stack itself. If you go to take the latter of these first, the BOP stack, this is illustrated to the right, where we have displayed sensors at two cross sections, typically in sets of 3 sensors, each with a sensory interface module, so that we can have redundancy. We have full redundancy. You could say we can measure moments in 3 of the sensors. We can combine the 3 and get better resolution. And these sensors measure typically micrometer precision, and we use isolated power and communication to ensure that we have a redundant system. To the left, we have a typical BOP monitoring system. In this case, it's a cable system to the top side. We use the same subsea or sensor integration unit, integrating motion reference units and typically either strain gauges or displacement sensors. So this is typically where we meet Cognite. There is a need for this information up and to share it onshore and offshore, and to have the data available for further processing. So if you go to the next slide, please. So while the video comes up, this is a dashboard that we have developed for BOP monitoring system, where the purpose of the dashboard is actually to ensure that the riser and the BOP is aligned. That's why we have the bullseye up to the right, where the small blue dot is the lower part of the BOP connected to the well, and the green is the riser signal. And you can see the signals as the timeline curves, either blue or green for the BOP in the 2 directions, roll and pitch. And the red curve is the difference between the 2. So when you do the alignment, then you actually ensure that the green line is following the blue line. Note the difference in resolution. So it's actually a factor of 10 between the movements of the BOP and the riser. in this case. So I'll leave the word now to Trond from Equinor. So next slide, please.
Hello, I'm Trond from Equinor. I work as lead subsea engineer in Equinor. We do planning and execution of offshore drilling operation. My first slide. I want to give some reflection from the end user perspective of how and what we use this monitoring system to on subsea well. First, I want to show you how this setup looks like. So on the left-hand side, on the picture with the drilling rig and the marine riser, you can see the overall setup. From the drilling rig, there are marine riser connecting the drilling rig to the BOP sitting all the way down at the seabed. The BOP itself are locked down to the wellhead, and the wellhead is the crucial part which I'm going to come back to. The BOP itself are typical from 200 to 400 tons, 10 to 50 meter high, and environmental loads, they are acting on this vertical stack and transferring forces into the wellhead, sitting in the ground as part of the well structure. Going a bit to the right here, you see the wellhead with the BOP on top. And a bit more to the right, you see an example of a BOP sitting on a rig. And all the way on the right-hand side, you see the monitored, instrumented part of the BOP. The yellow and gray sensors there are what the force are instrumenting the BOP with. So here we get data up to surface, so we can read them live. Next slide, please. To further explain why we use monitoring system, I just need to say a few words about wellhead fatigue, because that's the kind of the hazard we are mitigating by using this instrument. On the right-hand side here, you see a typical well structure, and the upper part here, that is the wellhead, which the BOP lock onto. And I have just copied in from the textbook here. As you see, the fatigue itself, that comes from cyclic loading. And cyclic loading is something we get from rig movement, riser movement over time. It is in the welds and notches in the wellhead. That's what we are most worried about, because we get stress concentration there. Another crucial part of the wellhead is that it's an expensive part of a well slot if you're going to reuse it. For the business case, it's very important to reuse it. It's not kind of the wellhead itself that costs so much, but it is the operation to change it out. So this is the thing, it's crucial with wellhead fatigue, and it's also to replace it is costly. Next slide, please. So I'm going to try to elaborate a bit on some questions here and try to answer why we're using this and what is the advantages with data collection from subsea wellheads on drilling rig. So what have triggered instrumenting of the BOP? That is what I've been talking a bit about here. It's the wellhead fatigue. That is have been driving this, that we want real-time data down here, not just conservative analysis. So why do we instrument BOP and collect data? We can get real data measurement from the actual operation we are performing. We can also post-process or analysis with real data. And it's also a tool for decision making. If we see something here, we have the data to better decision making. And at the very end, what advantages have we got with this technology? We have more accurate analysis. We can actually base it on measurements. We can have continuous analysis running and redo the analysis as we are on the well. And eventually, it's also allowing more operation on well slots. Thank you. Then I give the word further.
Thank you so much, Trond. That was excellent. So moving on to some other examples. This is also from the oil and gas industry, where we have a sensor solution which we have just recently been working on. This is a replacement of a faulty load cell for a tension leg platform tendon. So there are a number of aging platforms around the world, and this solution can help ensuring the safety and integrity also after the original monitoring systems stop working, and you have life elongation of the platform system. So here we have developed a bracelet solution that we can strap onto the tendon, and that provides accurate strain measurements for the tendon. So in this particular case, we have 4 redundant sensors on each bracelet that measure the strain down to ±5 microstrain. And the system is installed by diver just below the pontoons as indicated in the figure. If you go to the next one, Petteri, we can see the animation of the film from the installation. So here you see the bracelet installed subsea after the diver has done its operation, and it's in place. Anything to add on this one, Paul?
No, I think it was a smooth installation, and it gives precise data and information.
We can move on to the next one, Petteri.
So the next example is from a different business. This is aquaculture, where we have been involved in design of a closed cage system. And the task in hand for us at this time was actually to calibrate and verify the structural model of a fish farm built with these cages. And the cage is held up, floating by a concrete collar consisting of 8 elements. And what we did was we instrumented both ends of this fish farm with sensors. The fish farm consists of 12 cages, so it actually spans 70 by 200 meters approximately. And the idea is actually then to see what happens with this when it's exposed to the environment, in this case waves. So we put sensors on the wires, measuring tension in the wire, holding the collars together. We put sensors, load cells, typically on the wires between the cages, like in 2. We had mooring line tension on critical mooring lines. We had accelerometers on the pontoons to measure the movement on the different pontoons. We had wave and wind current measurements with using seabed instruments looking up, and we had wind sensors sitting on the system. A total of approximately 80 sensors that we collected in the monitoring station and sent it to the cloud storage for processing. So the next slide, please.
Yeah, so here we can see how we have used the sensor data to feed back into the structural model. And we have used the sensor data to calibrate the structural model in order to make more precise simulations for the future. So basically we took out data from the mooring lines, as is shown here, basically the forces in the mooring lines. And we sort of recalibrated until we were able to capture the dynamic behavior of the whole model. And with that calibrated analysis model, we have a very good representation of the dynamic behavior. That in turn leads to improved design. We saw For instance, some improvements that would be made in the next generation. We also saw and learned that our initial structural models were too stiff in, for instance, the connection between the colors, among other things. And by improving those data, we were able to improve the whole behavior of the design. And also we found that the acceptable sea states for this facility were actually, it was more robust than originally anticipated. So that was a very good learning. And also we do have a digital model to aid in future facilities. So just want to mention that Aquafuture, they develop these fish farming concepts. It's very future oriented, very environmental friendly. I mean, it's louse free, and it's preventing the salmon from escaping these cages. So it's a very, very good solution for the future. Next slide, please. So moving on to what we do in offshore wind. So we, as mentioned, we do a lot of structural design and analysis with structural integrity, third-party verification, advanced engineering, and design analysis. But most prominently, we design foundation structures, both for wind turbines and for trafo station, this HVDC transformer stations that's used for this big new offshore wind farming facilities. Forsen's monitoring systems we have been through, basically the load monitoring part about what we do, but we also do corrosion monitoring in addition to the dynamic and mechanical monitoring that we have discussed. And we also do a lot of cathodic protection management and design for the offshore wind. If you move on to the next one, Petteri. So just want to say a few words on the capabilities we have on inspection. We also make these systems for scanning of blades for the wind industry. So this is things that are from our mother company in Denmark, and I think we have at the moment the best solution for this blade inspection during fabrication available on the market at the moment. We also do drone inspection of blades and also thermal scanning, and we have crawlers that we send up on both the blade scanning and the towers. And we also do coating and paint inspection, and also foundation inspection during the fabrication, as mentioned. If you go to the next one. So here is some of the stuff that we are doing in our testing facilities and laboratories. So as mentioned earlier in the presentation, we have wind tunnel testing and we have water testing. And what you actually see in the top pictures there is a combined wind and water testing of a floating wind turbine design that we actually made 10 years ago. Way ahead of its time, but a really great project. What you see to the right, top right, is a full-scale testing of a jacket node. And also to the bottom middle, you can see the testing facility that we use to test these blades, full-scale testing of windmill blades. And we also have climate chambers for testing of turbines and blades. In addition, we do failure investigation, mechanical testing, and also microscopy and microstructure analysis, steel, composite, and concrete. So I think with that, I will conclude our end of the presentation and leave it back to Cognite.
Very, very good. Shall we then jump on to the questions? I have a couple ones here that have come in from the audience, and please do keep on posting your questions should you have any. One that came in as we were discussing the value of liberating data, moving into the cloud for the analytics part. There's a question: how did you go about developing and operationalizing your cloud analytics solutions prior to your engagement with Cognite? And what has been the major difference in your interaction with Cognite now versus what you were doing before? And I guess this is equally to either one of you gentlemen from Force Technologies, so you can pick between yourselves who wants to go first, and the other one can of course add flavor and color.
You want to make a stab at that one, Paul?
I guess, yeah. Like Alexander said, we actually made a solution ourselves, based on experience from our IT departments and software engineers there, and it worked. Definitely, and we got data into the cloud. What we discovered was that the flexibility in the tool was limited. So what we have discovered with Cognite is that we get a solution that is easier to adopt, and we can easily process data and we can visualize data. Very simple. So it has been an improvement. At the same time, we release our resources internally to do other stuff. That's important for us.
No, I agree to that one, Paul. I think the solution that we developed ourselves was a very bespoke one-off solution. That if we wanted to continue with that one, we had to do a lot of work and get resources to work on it. Whereas with Cognite and the data fusion system, the data is very accessible and it speaks to a lot of public domain software that is open software and very easy to tailor to the exact application. So that's given us more freedom and more confidence basically in making new applications for this.
Very good. And then there's another one. The presentation started with oil and gas, very subsurface centric, and then very quickly you moved and showcased your capabilities and competencies and offerings in wind. Where do you see the wind industry evolving, and in your particular case, what are the biggest challenges that your customers are facing with operationalizing and scaling their windmill farms, especially in offshore condition?
I think that's a very good question because usually we will monitor wind farms, right? And why do we monitor wind farms so extensively? So that is being done, right? So usually in a park you will monitor like 10% of the turbines and maybe even some of the structures on the trafo stations. And the question, the way it's heading, I mean, it's two things you want to achieve. It's life extension. So basically, if you design a wind park to, let's say, 25 years or 15 years, you want it to last longer because, I mean, by that time it's paid down, and every year you can make it last and bring in money. It's money in the bank, right? And secondly, it's about if you want to sell off your wind park, you can actually demonstrate that by monitoring your facilities, you can have a look at what the actual weather conditions compared with what you have designed it for. Have you designed it for a 50-year storm, 100-year storm, and so forth? And how many of those have it actually seen during the last years? And by that, you can extrapolate or extend the life expectancy and thereby increase the value of the wind farm. So that's the two other things we're discussing with our customers. Yeah.
And there's one on analytics itself. Structural integrity comes across as being very physics reliant. What is the actual role of machine learning or modern computational analytics, or is it still very much in the realm of physics-based simulations? And where do you? And I'll add my own flavor to it. Where do you see that going in the next 5 or 10 years?
I think that's super exciting. One customer that I interviewed actually said that you guys need to be careful because your physics-based models are going to be replaced by machine learning models. So that the IT dudes are going to take over for your physical experts and so forth. I don't think so. I think you need to have that physical understanding that we are putting into the models. But on the other hand, the machine learning side is moving very, very rapidly, and a lot of exciting things are happening. However, I think there's room for both. And I think using both is going to bring a huge improvement in the way that we look at structures and structural analysis and online structural analysis. I don't know, Paul, if you want to add anything to that.
Well, I guess machine learning can give us insights into elements that we don't know or don't have experience with.
We have at Cognite, we have a lot of our data scientists who are very, very bullish on the role of physics in the to-be industrial optimization scenarios. We talk a lot about physics-guided machine learning, or hybrid AI, as it's also called sometimes. I want to ask one question myself, just piggybacking on the previous one from the audience. If you were to give a forecast in terms of how much weight does the machine learning side hold versus how much they still rely on the first principle of physics by 2025, so let's take a meaningful midterm time span, where do you think the industry is going to be? Are we going to be overwhelmingly on the machine learning side, or is it still going to be fundamentally powered by the good old conventional first principles?
From my point of view, we still have a lot to learn and develop around the machine learning. I think it's a so rapidly developing field that it's very difficult to predict. But I will put my money on the physical-based models at least up until 2025. Come 2030, I think the picture will be a little bit different. But for the foreseeable future, you need to have that physical understanding and that physical-based models. But that's kind of my take on it.
And then it's also, of course, people have a lot of confidence or trust in good old physics. And again, noting my laptop freezing or the battery of it freezing here in this current climate, I would put my trust in having a better equipped laptop next round as well. So again, perhaps there is a lot of sense, common sense in keeping with the thing that you know actually works, as opposed to pushing the boundaries all too much. One final question from my side. If you look at your business area, and you certainly deal with a lot of different customers in different regions as well as in different
Lost you a little bit there, Petteri.
industries, how much of a shift are you seeing in conventional energies and that goes into renewables versus how is that driving? Is it taking a bigger role over the next 3 or 5 years? So still staying in the medium term.
I think you need to repeat the question because you fell out during that.
Did you hear me, or do I? Yes. Okay, apologies for that. So looking at the renewables change, and you have customers across lots of different industries and lots of different geographies, how do you see from your perspective the energy transition playing out for your customer base, and how does that impact your business? And how do you see the medium time frame in that? And what are you doing, quite frankly, to prepare for it?
Well, I'm not sure if I picked up your question right, but in terms of what we are doing, Force Technology as a company is working on the machine learning. We are employing that in a number of our solutions. But I think from our perspective, it's going to need a lot more experts, and getting access to those experts and data scientists and the people that can actually do these things is going to be difficult. And I guess those competitors that actually get hold of those experts will have a huge advantage. And also it's about our customers adopting to these solutions and putting trust in these solutions. And I think that's going to be more and more. And I think as these gain traction, I think we're going to see a lot more of it. And if you want to stay in the race, you have to do work in that direction.
I think when it comes to renewables compared to our base today, I think we are going to do much more in the renewables area, and Force Technology has a strategic point on that, moving into the renewables.
And Tor, you mentioned skills, competence, the right people. How do you see the balance between people, skills, and technology itself? There's obviously a lot of fight and battle over the right skill sets right now. Do you see that gradually shifting over or evening out as the machine learning, for example, settles in and becomes more understood and more commonplace? Or do you see the battle for talent continuing to get even worse from where it is now?
Oh, I think the battle for talent is going to be with us for some time. I mean, right now we have an unprecedented upturn in the oil industry and also in the renewables industry. And I think we are going to see a lot of fight for talent between these areas, because things are growing so fast at the moment that it's difficult to fathom actually how fast. But I kind of think that the ones that will win in this race is the ones that have good resources with good solid competences in different areas that can match these and combine these with the experts in machine learning and data science. I think that we will come to a point where data scientists can only do so much, but we also have to understand the physical aspects of what we are trying to measure, model, and interpret. And I think the companies that will succeed in the future is the ones that are able to match those resources.
So based on that, it certainly seems like you, gentlemen, and Force Technologies at large is in a prime position to capture on the exciting opportunities that we all have ahead of us. So with that, and I'm looking at the questions, there are no new questions from the audience. So I'd like to thank you, gentlemen, for taking the time today. And I do look forward to seeing you gentlemen again. And to the audience, thank you for joining us today. Thank you for taking the time. And we will make the recording available shortly afterwards. And hope you all have a fantastic day. Thank you.
Thank you so much, Petteri. It was great fun. Thank you for having us.